Hello students, welcome to my YouTube channel Dear Mathematics and also welcome to the chapter of sequence and series. In this topic we are going to discuss about sequence and then series. How many types of sequence are there, how many types of series are there. Then we will study about the arithmetic progression, geometric progression, harmonic progression and also arithmetico-geometric progression. Before going to analyze that, let us look at the definition of a sequence. What is the definition of a sequence? A sequence is a function whose domain is the set of natural numbers. That means, let us consider there is a function f in between two sets. If this domain part is the set of natural numbers, then we can call it as a sequence. Then moving towards to the real sequence. The real sequence is the next part of the sequence. That means f is any function in between two sets. The first set must, the domain must be the set of natural numbers. Then it will be a sequence. But we have to find out what is a real sequence. If the range of a sequence is a subset of a real numbers, then it is called as a real sequence. That means it is the domain part. But we have to find out the range part here, and this range part must be a subset of the set of real numbers. Then we can call it as a real sequence. So there exists a single condition. Just we have to show that the domain is a set of natural numbers, then it is a sequence. But in the real sequence term, we have to show that the domain must be the set of natural numbers, and also the set of the range must be the subset of the set of real numbers. Then we have to go for the another definition is there for the term sequence here. A set of numbers arranged in a definite order. Here is the first condition. According to some rule, here is the second condition, is called as a sequence. Generally, we use this definition in our chapter rather than this definition. A set of numbers arranged in a definite order and according to some rule is called a sequence. The sequence or the number of terms which obey both of the conditions is called as a sequence. Example. Suppose I have taken here 2, 5, 8, 11, ... Here you can see that whether this set of numbers satisfy both of the condition or not. We have to check it. First of all, moving towards to the order part, definite order. It satisfies the condition of definite order because you can see that this is in the increasing order. 2, then 5, then 8, then 11. You can see that it satisfies the condition of the first condition, that means definite order. Then we have to go through to check the second condition, that means there must exist some rule in between the elements. You can see that 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11. That means each and every term except the first term can be obtained by adding plus 3 to its just immediate previous terms. So it also satisfies the fixed rule. That means both of the conditions are satisfied here. So here we can say that this is a sequence. This is a sequence. Let us consider another example. Suppose we have taken 5, 3, 4, 8, 2.5, ... We have to check that the set of numbers is a sequence or not a sequence. First of all, we have to go through the two given conditions, whether they satisfy, whether the set of numbers satisfy both of the conditions or not satisfying. First of all, we have to check the definite order. This is not in the increasing order, this is not in the decreasing order, also the elements are not same. If the elements will be same, then this will be a order. But this is not in the not in the decreasing nor in the increasing, so it is not satisfying a definite order. So we don't need to go for the rule part because it is not satisfying the first part. So we don't need to check the second part, and we can just write down here this is not a sequence. Okay, let us go through another example. Suppose I have taken 32, 16, 8, 4, and we have to check it whether it is a sequence or not a sequence. The first part is here, we have to check the definite order, and then we have to check the fixed rule. Yes, it is satisfying the definite order because you can see that this is in the decreasing part, all the terms are in the decreasing order. Then we have to go for the rule, whether it satisfies some rule. Yes, it satisfies some rule. 32 divided by 2 is 16, 16 divided by 2 8, 8 divided by 2 4. So it also satisfies the fixed rule. So you can say that it is a sequence. It is a sequence. So this is all about the definition of a sequence and also real sequence. Then let us move through the topic of a sequence by taking or considering some of the more data fundamental of the sequence and series. The numbers of the sequence are called as its terms. The numbers of the sequence are called as its terms. The first term is denoted by A1 or A2, A1 or T1. You can denote it as A1, either A1 or T1. Similarly, the second term is denoted by A2 or T2. Similarly, the third term is denoted by A3 or T3. Similarly, the nth term is denoted by An or Tn. So these are the terms. The sequence can be denoted by, generally the sequence is denoted by, either A1, A2, A3, An or T1, T2, T3, Tn. This sequence is also denoted by the sequence is denoted by like this manner. Generally we use this two rather than this two. Then moving forward to the next fundamental of the sequence chapter, the nth term is also called as this term an or tn is also called as the general term. The nth term of the sequence is also called as the general term of the sequence of the given sequence. So this is all about the fundamental data of the topic sequence. What is sequence, what are the terms, and what are the notation of to denote the terms of a sequence, and then what is the general term. Then let us moving towards to the some of the examples based upon the definition of sequence. So here it is the example based upon the definition of a sequence. That means a function is given and it is also given that the domain is the set of natural numbers, because if the domain is the set of natural numbers, then we can call it as a sequence. And from here, from the given data or from the given function, we have to find out the sequence associated with the function. Let the function be f of n is equal to 2n minus 1, where n belongs to the set of natural numbers. This is the set of natural numbers and this is the function f, and it is a sequence because the domain is the set of natural numbers. But first of all, we have to find out all of the terms associated or present in the sequence. If n is equal to 1, then first term t1 is equal to 2 into 1 minus 1, that means 1. This is the set of natural numbers. If n is equal to 2, then second term t2 is equal to 2 into 2 minus 1, that is equal to 3. If n is equal to 3, then third term t3 is equal to 2 into 3 minus 1, that is equal to 5. Similarly, if we are going to find out the nth term, hence nth term tn is equal to 2n minus 1, that means it is the general term. This is the general term. Hence the sequence is 1, 3, 5, dot, dot, dot. You can also write down the last term 2n minus 1, but no need to write down the term. The general term is of the given sequence is tn, because the general term is the nth term, and that is 2n minus 1, where n belongs to capital N. So this is all about how can we find out the sequence from a given function. In the later part of this video, you will also find out the sequence from the nth term of a given sequence. So let us discuss about more of the fundamentals based upon the chapter sequence. How many types of sequence are there? That means types of sequence. Now let us discuss about the types of sequences. It is of two types. It is of two types. The first one is finite sequence, and the second one is infinite sequence. First of all, let us discuss about finite sequence. The sequence which contains a finite number of terms is called as a finite sequence. The first one is finite sequence. The sequence which contains finite number of terms is called as a finite sequence. Example. Suppose I have taken an example of 1, 3, 5, 9. It is a finite sequence. This is a finite sequence. You can call it as is a finite sequence. Is a finite sequence. Similarly, infinite sequence. Just considering the definition of finite sequence, you can also write down the definition of infinite sequence. The sequence which contains infinite number of terms or numbers in a sequence is called as infinite sequence. The sequence which contains infinite number of terms is called as an infinite sequence. Example 1, 3, 5. Here the last term is not given. That means it is an infinite sequence. Here the last term is given. So the fundamental is based upon the last term, whether it will be finite or it will be infinite. As the last term is not given, here, so it is an infinite sequence. Is an infinite sequence. So basically, sequence is of two types: finite sequence, infinite sequence, based upon the number of terms present in it. But except the finite sequence and infinite sequence, there exists another sequence which is called as a Fibonacci sequence, and which is different from these two sequences, because this is very much the fundamental of the Fibonacci sequence. It does not match with the finite sequence and infinite sequence. It has a separate fundamental. So here it is the Fibonacci sequence. It is an exceptional sequence where each term after the second term is obtained by adding its previous two terms. That means we have to find out, or we have to determine all the terms, but after the second term. That means from the third term by adding its previous two terms. Generally, we write the formula as Tn is equal to sum of Tn minus 1, its previous term, then with its previous term, that means Tn minus 2. Where n is greater than or equal to 3, that means we have to define the terms from the third term only, because the first two terms are fixed. Here T1 and T2 both are equal to 1. Here first term and second term are both equal to 1, and it is fixed. You cannot change them. Then in that condition, using this condition, we can define the Fibonacci sequence. So as T1 is equal to 1, T2 is equal to 1, then we have to go for the determination of T3. T3 can be determined by using this formula. T3 can be determined by T3 minus 1, that means 2, plus T3 minus 2, that means 1, and the value of a T2 and T1 both are 1. 1 plus 1, that means it is equal to 2. Then T4 can be determined by T3 plus T2. Similarly, T5 can be determined by T4 plus T3. T6 can be determined by T5 plus T4. So let us evaluate the values of all of the three numbers here. T3, that means 2, plus T2, it is 1, it is 3. T5 can be determined by adding T4 and T3. T4, it is 3, plus 2, it is 5. T6, then it is 5 plus 3, it is 8. Similarly, we can also determine T7, it will be the sum of T6 and T5. T6 is 8 plus T5, it is 5, that means it is 13. So at the conclusion, we can also write down the Fibonacci sequence is given by 1, 1, 2, 3, 5, 8, 13, because it is an infinite sequence. It is an infinite sequence because infinite number of terms of the Fibonacci sequence can be determined by using this general formula. So you can also write down it is an infinite sequence. It comes under infinite sequence. So a Fibonacci sequence is an exceptional sequence and it is not in the category of finite and infinite. It comes under the infinite sequence. Then let us discuss about some of the fundamental parts of the sequence and series chapter, and that is series. What is the definition of series and types of a series? How many types of series are there? Now let us discuss about the term series. What is series? If A1, A2, A3, an be any sequence, then the sum of all these terms, that means A1 plus A2 plus A3 plus an plus the further terms, is called as the series associated with the given sequence. And here it is the definition. If A1, A2, A3, an suppose there are some further terms after the nth term, be any sequence, then the expression, that means sum of all the terms, is called as a series, but it is associated with the given particular sequence. Then moving towards to the types of a series, and it is of two types. Like the sequence, series is also divided into two types. It is of two types. The first one is finite series and the second one is infinite series. Infinite series. So let us discuss about the finite series. What is finite series? If the sequence is finite, then the series obtained from that sequence is called as the finite series. If the sequence is finite, then the series obtained from that sequence is called as finite series. Example, 1 plus 3 plus 5 plus 19. That means this is the last term and there are no further terms after 19. That means it is a finite series. Then let us discuss about the infinite series. Infinite series. Just considering the definition of finite series, you can also write down the definition of infinite series. If the sequence is infinite, then the series obtained from that sequence is called an infinite series, is called an infinite series. Example, you can also take an example here. Suppose I have taken 1 plus 3 plus 5 plus 7 plus dot 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 plus 19 plus dot dot dot. That means there exist some more terms after the 19 term, after this term 19. So for this, due to this reason, you can call it the series as infinite series. So it is all about the topic of a series, types of a series. Then let us solve some of the basic problems for the today's video session, and let us define some of the sequence from the given nth term of that sequence. So here it is the first problem based upon the today's video session, and the problem is like this: find the first 5 terms of the sequence whose nth term is given. That means we have given the nth term of that sequence, but we have to find out the first 5 terms. That means A1, A2, A3, A4, A5, or also you can write down T1, T2, T3, T4, T5, but as the nth term is given in terms of An, so we have to just find out A1, A2, A3, A4 and A5. So let us solve it. Given that An is equal to 2n plus 3 divided by 6, when n is equal to 1, then A1 is equal to 2 into 1 plus 3 divided by 6. That means it is 2 plus 3 divided by 6, and it is 5 by 6. When n is equal to 2, then A2 is equal to 2 into 2 plus 3 divided by 6, that means 4 plus 3 divided by 6, and it is 7 by 6. When n is equal to 3, then A3 is equal to 2 into 3 plus 3 divided by 6, and it is 6 plus 3 by 6, that means 9 by 6. When n is equal to 4, then A4 is equal to 2 into 4 plus 3 divided by 6, that means 8 plus 3 divided by 6, and it is 11 by 6. Similarly, when n is equal to 5, then A5 is equal to 2 into 5 plus 3 divided by 6, and it is 10 plus 3 divided by 6, and this is 13 by 6. But we have to write down the complete answer. The first 5 terms are, the first 5 terms are 5 by 6, then 7 by 6, then 9 by 6, then 11 by 6, and 13 by 6. And this is the first bit of the given example number 1. And the second one is tax for you. It is the tax for you. You can also consider another example. Suppose I have given another problem for you, and here the nth term is like this: minus 1 to the power n multiplied with 3 to the power n plus 2. Write down this question and solve it, and find out the first 5 terms of the given sequence, where the nth term is like this, and both of the questions are tax for you. Then let us moving towards some of the more problems. So these are the last 2 problems of the current video session based upon the topic sequence and series. And in the example number 2, it has been given that the nth term is like this: an is equal to n into n minus 1 divided by n plus 3. Just we have to find out the 15th and 21st term. And this is very much easy problem, and these are not important for the board exams. Given that an is equal to multiplication of n and n minus 1 divided by n plus 3. The 15th term, that means T15. Okay, you have to write down A15. A15 is equal to 15 into 15 minus 1 divided by 15 plus 3. And this is 15 multiplied with 14 divided by 18, and just you have to solve it. Similarly, the 21st term, it is the 15th term. 21st term is equal to A21, and it is 21 multiplied with 21 minus 1 divided by 21 plus 3, and this is multiplication of 21 with 20 divided by 24, and then again you have to solve it to find out the proper answer or simplified answer. Then let us solve the last problem of this current video session. In this problem, it has been given that the first term is given, and there is again a condition, and we have been asked to find out the first 4 terms. The first term is given, that means we have to find out the next 4 terms. And here n greater than 1. So here it is the solution. Given that a1 is equal to 2, that means the first term, and the general form to define the all of the terms of that sequence is given, and this is an is equal to 4 multiplied with 4 an minus 1 plus 3 for all n greater than 1. And we have to apply this form to find out all the terms whenever n is greater than 1. This is not applicable for the first term. So here, when n is equal to 2, then a2 is equal to 4a 2 minus 1, that means 1 plus 3, and the value of a1. Okay, first of all let us see how this evolves. 4a 2 minus 1 plus 3, that means 4a 2 minus 1, it is 1 plus 3. The value of a1, it is 2, 4 into 2 plus 3, that means 8 plus 3, and it is 11. Then when n is equal to 3, then a3 is equal to 4a2, because 3 minus 1, it is 2 plus 3. The value of a2 is 11. 4 into 11 plus 3, that means it is 44 plus 3, it is 47. When n is equal to 4, then a4 is equal to 4 minus 1, that means 3 plus 3, then 4 multiplied with 47 plus 3, then just solving it is 188 plus 3, and that is 191. And it has been asked to find out the first 4 terms of the sequence, that means a1, a2, a3, a4. Hence, the first 4 terms of the given sequence are, the first one is 2, then 11, then 47, and 191, and this is the complete solution. So in this video session particularly, we have just started the topic of a sequence and series. In the latter part, we have to start the arithmetic progression, geometric progression, harmonic progression, and also the arithmetic geometric progression. But in this particular session, we have just seen, or we have just analyzed the topic of a sequence, the different types of a sequence, then series and different types of a series, and also the exceptional sequence, that is Fibonacci sequence, and also we have solved some of the important basic problems based upon the topic, sequence, and series.